Hey there, this is Dr. Ramey. I'm going to go over some sample problems of how to calculate the number of bacterial cells. So if we look at this practice problem here, if a culture of E. coli containing 1 million cells is allowed to grow for an additional 15 hours under ideal conditions, how many total cells are in the culture? So I expect you to know the formula, right? And that N naught is the initial number of cells, that little n is the number of generations, that n sub n equals the number of cells after n generations. And in this case, I would expect you to know that the doubling time for E. coli under ideal conditions is 20 minutes. So given all this information, we're looking for the total number of cells after 15 hours. We need to know how many generations there are. So there's, N naught is 1 million cells. So we're just going to say 10 to the 6th CFUs. You can write cells if you want there. And then it's going to be 2 to the n generations. So how many generations are there? Well, we've got 15 hours here at 20 minutes per doubling time. That's 3 doubling times per hour, and then 3 times 15 is 45. So there's 45 generations. So this is going to be 2 to the 45. And let's see here. We're looking for 2 to the 45. So let's see here. 2 to the 45 is 3.5 times 10 to the 13th. Okay, 3.5 times 10 to the 13th. Okay, so this would be 10 to the 6th CFUs times 3.5 times 10 to the 13th. And when we multiply these numbers like this, we can just add the exponents. So this would end up being 3.5 times 10 to the 19th cells, or CFUs. 3.5 times 10 to the 19th. And just to double check, I solved this problem earlier, and in fact, yes, 3.51 times 10 to the 19th CFUs. Okay, good. So let's look at one more practice problem here. Now, what I recommend that you do is to pause the video, take a look at that practice problem, and then solve it. And only when you have solved it, resume the video, and then I'll solve it and we'll see how you did. So pause the video now and come back when you've got an answer. Okay, so let's see how you did. So we've got Clostridium perfringens with an N naught of 5 times 10 to the 5th cells. And you're incubating it for an additional 5 hours, and I'm telling you in this case that the doubling time is 10 minutes. Any other organism other than E. coli, I would give you the doubling time. Okay, so that means the doubling time of 10 minutes, that's 6 generations per hour times 5 hours, so the number of generations is 30. So N naught is 5 times 10 to the 5th CFUs. That's our amount of cells that the culture starts with, and then 2 to the 30th. Here's my calculator. I'm going to figure out what 2 to the 30th power is here, and that is 1.07 times 10 to the 9th. So this would be 5.0 times 10 to the 5th CFUs times 1.07 times 10 to the 9th. Okay, so 2 to the 30th power is indeed 1.07 times 10 to the 9th. So this would be, so 5 times 1.07 is 5.35. And then this is 10 to the 5th, this is 10 to the 9th, so this would be times 10 to the 14th. And this would be cells, or we could just write CFUs. So the answer is after culture that starts with 5 times 10 to the 5th cells. After 5 hours, the total number of cells in the culture would be 5.35 times 10 to the 14th cells, or CFUs.